Hello everyone. So we have a good question from the chapter of sound. So uh, seeing the graph, we can assume or not assume, it's quite obvious that the density of this string or this of this string here, it varies. Okay, and it varies linearly with the length, as we can see over here, right? And yeah, it has all been written in the question, and we have to find the time after which the disturbance created at one end will reach the other end. And some values are also given, like A is the cross section area and T is the tension in the string, which happens to be constant. Okay, so yeah, let's start with it. First, let's try to solve this graph. Okay, let's see. इसमें से एक equation आएगा. uh, if we'll simply write the straight line equation, you remember that, right? uh, just a second. Yeah, like y1 minus y2 by x1 minus x2 is equal to y minus y1 by x minus x1, right? With the help of this equation, we will try to get the value or get an equation of the density, okay, which will of course depend with length. So if we follow this graph, we will see that rho naught minus 0 divided by L minus 0 is equal to rho minus rho naught by L, or rather let me write small l minus capital L. Okay, so upon solving this equation, we will get rho is equal to rho naught L by capital N. Okay, this is the equation of rho, of the density, how it varies with length. So we have been asked to find the time, right? So let's do one thing. We know the value, like the formula for finding the speed, right? Speed of sound in a string, which is v equal to root t by mu, right? Now in this particular question, this quantity mu is variable, right? It varies with length. So we will again have to use integration. So dx dt is equal to root t by mu, where t is constant. Okay, so dx dt is equal to, or rather not dx, it will be dl, right? Because the variable here is L. So the tension is constant and mu is mass per unit length. Okay, so the mass is rho naught L A, right? Very obviously, because density into volume, right? That is the mass. And this will be divided by the area, right? Or I'm sorry, rather the length. This entire thing will be divided by the total length. Okay, so yeah, this will be root L dl. This will be equal to root t capital N by rho naught A dt, right? So now let's just integrate both sides. So this will be equal to L to the power 3 by 2 divided by 3 by 2. This will be equal to root TL by rho naught A. Integrating dt will just be t, because there is no variable t on the right hand side. So when t is 0, the small l is 0, and when t is uh, when t is t, I can't write capital T because it's equal to the tension, right? At that point, the length of the wire which it has covered, which the sound wave has covered, is capital L, right? And yeah, it's very straightforward right now. So the value of time which it will take will be 2 by 3 root rho naught A divided by T into L. Okay, this right here is the answer for this question. Very unsurprisingly, you will find that the velocity, or rather the time which the sound wave takes from moving from the bottom of the string to the top of the string, will be the same amount of time which the sound wave takes to come from the like the top of the string to the bottom of the string. Okay, you can do that integration on your own. It's very straightforward again, and yeah, you will find the same answer. Okay, here's the answer. Thank you.